Hi all, this is Shamla Devi. Welcome to this session, Unit 2 Virtualization. Virtualization is a fundamental concept that powers the modern IT systems, cloud services, and enterprises computing. In this unit, we will explore how the virtualization allows us to create the virtual versions of physical computing components such as servers, operating system, storage, and networks which help us to use the resources more efficiently, securely, and flexibly. We will explore the key concept in virtualization and how they support in modern IT infrastructure. Overview. The topic includes first one is web services, second one is a SOAP and REST, third is SOA, fourth is basics of virtualization, fifth is types of virtualization, sixth is implementations levels, seventh is tools and mechanisms, eighth is CPU, memory and input output virtualization, ninth is virtualization and disaster recovery. Let we see one by one. Web services. A web service is a software application or component that allows a different application to communicate and exchange the data over the network using the standard protocols. It enables the different systems to work together. Protocols used in web services are commonly uses HTTP and format like XML or JSON for data exchange. It is a platform independent where the language like Java, .NET, Python are being used because it follows the open standards. Features of web services. Web services offer several powerful features. First one is interoperability, where the applications on different platforms can communicate seamlessly. Standardized protocol, where the common standards like HTTP, XML, and WSDL are used. Loosely coupling. Systems don't need to be tightly integrated. Next one is discoverability. Services can be discovered via the directions like UDDI. UDDI is Universal Description, Discovery and Integration. Reusability. Once created, a web service can be reused across a multiple applications. Next is stateless communication. No client context is stored between calls, which simplifies scaling. Security support. Standards like WS Security provides authentication, integrity, and confidentiality. Web services example. In the first example, consider a weather app that needs a real-time data. It connects to a weather provider web services. Is nothing but a API to get the latest information. In the second example, it is a travel agency app that uses the web services to check the flight availability across multiple airlines, hotel-related services, and credit card services. In the both example, the app uses the web services to connect, communicate, and retrieve the information from another systems over the internet. Types of web services. There are two types of web services. First one is the SOAP, Simple Object Access Protocol web services. It is a protocol-based web services that uses XML languages. Second one is a REST. REST is a Representation State Transfer web services. It is a lightweight where the HTTP-based service architecture is used. First one is the SOAP, Simple Object Access Protocol. SOAP is a protocol that strictly uses XML to structure messages. It can run over the HTTP, SMTP, or other transport protocol. A WSDL file, nothing but as a web services description language, describes the services structure and communication format. SOAP support advanced features like WS security, transaction, and reliability, making it ideal for banking, enterprises, and mission-critical applications. However, it is heavier due to its XML-based structure. Second kind of web service is REST, Representational State Transfer. REST is the architectural style that uses a simple HTTP methods like get, post, put, and delete to perform the actions on resources. Data can be transformed in the multiple format JSON, XML, or plain text. REST is a lightweighted and easy to implement and test. It is a stateless, which means each request from the client to the server must contains all the information needed to understand the request. It is widely used in mobile and web applications because of its simplicity and speed. SOAP architecture. In SOAP architecture, at the top, the client prepares a request encapsulated in a SOAP envelope. The envelope consists of a header, which can include the meta information like authentication tokens, and a body that contains the actual payload or operation details. The message is transferred via a standard protocol, usually HTTP. On the other side, the server receives and processes this message, ensuring the reliable, secure communication even across the device platforms. Next is REST architecture. In this diagram, represent the simple and stateless design of REST architecture. The client sends an HTTP request to perform an action like retrieving and updating data. The server processes this request and response, which an HTTP response that contains the status codes and data, usually in JSON format. This architecture is widely used in web and mobile apps because it is lightweight, fast, and scalable. It supports the stateless communication, which means the server doesn't need to remember any past requests from the client to improve the performance and flexibility. Now we see the SOAP and REST comparison. SOAP uses XML and it is strict and heavy, while REST uses a lightweight format like HTTP, JSON. SOAP support stateful communication, where REST is stateless. SOAP uses built-in security standards, while REST relies on HTTP and OAuth open authentication for security. In general, REST is used for public APIs and web apps, while SOAP is preferred for secured and enterprise level applications. Next one is a SOE, service-oriented architecture. It plays a vital role in the cloud computing by enabling the services to be designed as autonomous and reusable models. When we implement the SOA in the cloud, we gain the ability to scale, update, or relocate the services without affecting others. Components used in SOA are service provider, service consumer, and service registry. Service provider, it creates and publishes the services. Service consumer, it finds and uses the service. And final is service registry. It acts like a phone book to register and discover the services. Virtualization. Virtualization is a process of creating a virtual versions of computing resources such as servers, storage, operating system, networks, or applications. It is the abstractions of hardware resources, where these approaches increase the utilization, reduce the hardware cost, and improve the flexibility and isolation. With virtualization, we can run the multiple operating system and application on a single physical machine. Basics of virtualization. Each virtual environment runs in the virtual machine called VM, which behaves like a real computer. These VMs are managed by a hypervisor which allocates the physical resources like CPU, memory, and storage. The benefit is that multiple VMs can run different OS like Linux and Windows on the same hardware, each in isolation. Next one is before and after virtualization allocation. In before virtualization, each application or OS required a dedicated server, leading to a underutilized resources. While in with virtualization, one physical server can run a multiple VMS, which increasing the hardware efficiency, scalability, and cost saving. Next, we're going to see about types of virtualization. There are different types of virtualization: server virtualization, desktop virtualization, network virtualization, storage virtualization, application virtualization. Each type addresses a different resources area in IT infrastructure and provides the benefits like efficiency, security, and simplified management. First type of virtualization is the server virtualization. Server virtualization allows a multiple virtual server to run on a single physical server. Each virtual server has its own OS and application, isolated from the others. This improves the hardware utilization, lowers the powers and cooling costs, and simplifies the management. Popular tools include VMware ESXi, Microsoft Hyper-V, and Xen. It has benefits like reduce the hardware cost and improves the server utilization. Now we're going to see about the server virtualization, how has been done. The left side shows a traditional setup, one OS per the server leading to low efficiency, while in right side shows a virtualized environment, multiple OS instances running on one physical machine significantly increase the efficiency and flexibility. This approach improves the server utilization and helps organizations save on hardware, energy, and maintenance costs. For example, instead of running 10 servers for 10 apps, we can run them as 10 VMs on one physical machine. Next comes the desktop virtualization. Desktop virtualization runs user desktop as a virtual machine on a centralized server. User access the virtual desktop remotely via the client's laptop or browsers. Tools like VMware Horizon and Syntex virtual apps and desktops are commonly used. It has benefits like centralized management and security access. Next we're going to see about how the desktop virtualization has been done. The left image shows a central server connected to a multiple clients. User access the desktop environment remotely. While in the right side image is highlights how different operating systems like Windows, Linux can be virtualization and access from any terminal. Next comes the network virtualization. Network virtualization abstracts the physical network hardware and creates the multiple isolated virtual networks on the same physical infrastructure. This improves the network flexibility, isolation, and resource allocation. It enables the rapid deployment of a virtual networks for new applications without needing new physical wiring. Popular platforms used in the network virtualizations are VMware, NSX, and Cisco ACI. We're going to see about how the network virtualization has been done. Network virtualization is the process of combining the network hardware and software resources into a single virtual network. This technology allows the multiple isolated virtual networks to operate simultaneously over a shared physical infrastructure as we discussed previously. In this diagram, we have two physical servers, end hosters, each hosting multiple virtual machines known as VMs. The vSwitches, which means a virtual switches on each server, handle the internal VM communication. These switches are connected to the underlying physical network, which carries the actual data. The network virtualization controller access through the APIs, where is used to manage the traffic routing, network policies, and isolate it between the virtual networks. Here comes the storage virtualization. In the storage virtualization, multiple physical storage devices are grouped into a single virtual storage pool. This allows for better storage management, higher availability, and seamless data migration. Administrator manages storage centrally, even if it is physically distributed. Tools included in storage virtualizations are IBM SAN Volume Controller and NetApp ONTAP. Nothing, it is a open network technology for appliances products. Now we are going to see about how the storage virtualization has been done. In this diagram, we see the multiple server and the storage arrays connected to a virtual layer. The virtual layer helps in simplified storage management by hiding the complexity of individual devices. Applications and user access the storage as if it is very a single entity without worrying about where the data is physically stored. Here comes the application virtualization. Application virtualization allows the app to run in the isolated environment on a host system without being installed directly. This helps avoid the compatibility issues, simplifies the software deployment, and enhances security. Where the common tools used in the application virtualizations are VM Thin app and Syntax Zen app. You can see about how the application virtualization has been done. Application virtualization allows applications to run in the virtual environment without being directly installed on the physical device. In this diagram, multiple types of applications like Oracle, SQL, email, file, print, and application servers are shown at the top. These applications are funneled through a virtual layer called powered by VMware that separated them from the underlying hardware. Next one is a implementations level. Virtualization can be applied at various system levels. First one is the ISA, instruction set architecture, where the virtualization CPU instructions is being done. Second one is the hardware abstraction layer. In this level, abstracts the hardware using the hypervisor, and third level is the OS level. It container and shares a common OS kernel. And fourth level is the library level. It virtualizes the specific program libraries. And last level is application level, which virtualizes the whole applications. Each level provides a different degree of abstraction and performance trade-offs. Five abstraction levels of virtualization from hardware to application. In application level, virtualization helps us to the application runtime level using tools like JVM or .NET to make the application independent of the underlying OS. In the library level, tools like VINA, LXRun, Visual Main Win, and VCUDA allows the application written from one OS to run on another by intercepting API calls. In operating system level, virtual environment like JAIL, ENSIM, VAPS, and FEM allows a multiple isolated OS instance to share the same kernel. In the hardware abstraction layer called HAL level, virtualization platform like VMware, Xen, KVM, which means kernel-based virtual machine, and DENAL, abstract hardware, so the multiple operating system can be run on the one machine. And last level is a instruction set architecture called ISA level. Tools like Watch, QEMU, and Dynamo emulator entire CPU instruction set allows the software to run on the different processor types. Virtualization tools. There are various tools for managing virtualization environment. First one is a hypervisor. Type 1 like VMware, ESI, and Xen, and type 2 is like VirtualBox. And second one is a container. Tools like Docker and Kubernetes enable the lightweight OS level virtualization. Another tools include KVM, which means the kernel virtual machine, QEMU, which supports the advanced virtual machine setup. Next one is the virtualization mechanisms. There are several techniques for virtualization. There are full virtualization, para-virtualization, hardware-assist virtualization, OS level virtualization, and emulation. Full virtualization is a guest OS run unmodified. In pair virtualization, the guest OS is modified to optimize the performance. In the hardware assistant virtualization comes modern CPU assist the hypervisor. In the OS level virtualization, container shares the host OS. And finally, emulation mimicries different hardware platforms allowing the cross-platform software execution. Each has a unique performance, compatibility, and use case consideration. Full virtualization mechanism. In the full virtualization mechanism, the hypervisor simulates the complete hardware so that unmodified guest OS can run. Privileged instructions from the OS are tapped and emulated by the hypervisor. This method ensures a strong isolation and the compatibility with all OSs. However, it may have the performance overhead. Example VMware, ESI, and Microsoft Hyper-V. Next is para-virtualization. In para-virtualization, the guest OS is modified to work efficiently with the hypervisor. It uses the hypercalls instead of CPU traps, improving performance. The downside is that OS must be aware it is running in a virtualization environment. Example, Zen hypervisor is a kind of a para-virtualization mode. Hardware assisted virtualization. In the hardware assisted virtualization, modern CPUs from Intel and AMD support the virtualization via special extensions, Intel VTX and AMD V. This allows the most guest instruction to run directly on the hardware without needing emulation. It boosts the performance and security and is now standard in most hypervisor like KVM, VMware, and modern hyper. Next is operating system level virtualization. In this, operating system virtualization is known as a container. Yet the container is an isolated application that shares the host OS kernel, making them lighter than VMS. Containers are fast, portable, and ideal for microservices. Unlike the VMS, container do not need a full OS, reduce the overhead. Tools like Docker, LXC, and orchestrated platforms like Kubernetes being used. And next is the emulation. Emulation replicates the entire hardware system in software. It allows the software from one platform to run in another. Example from ARM to run on another example 8086 processor. It is useful for testing system legacy support or running the different OS architecture. It is slower but offers a maximum compatibility. Virtualization of CPU, memory, and input-output. These are the three key resources that virtualization must handle. In CPU, via CPUs and time slicing is being done. In memory, throughout the virtual memory, mapping and ballooning is being done. In coming to the input-output devices, using the virtual NIC and vDisks are being used. All are managed by the hypervisor to ensure the performance and isolation among the VMS. CPU virtualization. The hypervisor creates a VPS known as a virtual CPUs which are mapped to physical cores and comes time slicing ensures that each VM gets a CPU time even with a few physical cores than VMS. This approach allows many VMS to coexist efficiently. Memory virtualization. In memory virtualization, virtual memory and ballooning is being done. Virtual memory, each VM believes it has its own memory. The hypervisor maps this virtual memory to the host physical memory. Under ballooning, it is a kind of a technique to dynamically reclaim the unused memory from the ideal VMS and reallocate it to another. It used to improve the efficiency on the host. Input-output virtualization. Under the input-output virtualization, virtual NICs and vDisk is being used. Virtual NICs is a network interface card. Each VM gets a virtual NIC for networking the map to the host physical NICs. It can be isolated or bridged for a network access. Wherein vDisk, which means virtual disk, in VMs use a virtual disk like VMDK and VHD stores as the files on the host. The hypervisor maps them to a physical storage. Disaster recovery in virtualization, a strategy to restore the system and data quickly after a failure. Virtualization simplifies the disaster recovery where VMS can be backed up, replicate, and restore quickly on the different hardware. In case of the disaster like the hardware failure or cyber attack, VMS can be migrated to back up the servers, minimizing the downtime and data loss. This makes the virtualization a powerful tool for business continuity. That wraps up our session on virtualization. You have learned about the web services, virtualization basics, types, tools, implementation level, and how the virtualization support the disaster recovery. Thank you for your attention.